All right, let's also mention here the idea of a cross product. Our dot product was a scalar unit. Well, it turns out the cross product of two vectors is going to be another vector. And and what it is, it's going to be helpful. What we want to do is cross two vectors together and get an orthogonal vector to both. And that's what the cross product is. It's an orthogonal vector to two given vectors. Orthogonal vector. Okay, so that's what the cross product is going to be. It's going to be an orthogonal vector to two given vectors. And so, you know, if you think about the two-dimensional case here, if we've got a vector here and a vector here, and we're going to cross A cross B, what that's going to do is it's going to give us the cross product will give us a vector that's coming out of the board. It's going to shoot off out from those two. And works the same in three dimensions. You know, if the one vector's coming out here and then the other vector, it's going to do perpendicular to both of those wherever it happens to be, or wherever those vectors are pointing. Yeah, on a two-dimensional, it's going to be straight out. Well, now, we'll talk about it can actually go the other way, too. It can go inward. You know, this one, this one comes out that way. I'll talk about that here in a second, though. It could come out or go the other way, okay? Go backwards. All right, here is the definition. So A cross B is that vector. Now here it is, the definition. All right, so we've got A cross B equals, so again this is going to be a new vector, and different from the dot product. Dot product gave us a scalar. Cross product is going to give us a vector. All right, so it's A2B3 minus A3B2. That's the first component. Second component then is A3B1 minus A1B3. And then the third component is A1B2 minus A2B1. And there's a pattern there, but I'll show you a better way. You don't have to remember that. There's an easier way to set it up. You might remember it for a while and then forget it, but there's an easy way to get that combination there. But what I was going to show you was here that this is indeed, this vector here is indeed perpendicular to both. How could I do that? How could I show that this right here is perpendicular to A and B? Well, we know when we dot product two vectors, we get 0. And if the dot product is 0, they're perpendicular. So if we dot product with the cross product, we should get 0, right? And do that with B, it should be 0 here. And that's not too bad. You know, I didn't write A and B down, but A and B are just the standard A1, A2, A3. But notice here, if I dot product this with that, what do I get? Just multiplying, right? A1 times that, so I get A1, A2, B3 minus A1, A3, B2, right? That one times that. Just distribute that A1 into those. Add to that then this one times this, So we have A2, A3, B1 minus A2, let's do A1, A2, B3. And then the other part of it would be that one distributed into that, right? So it'd be A1, A3, B2 minus A2, A3, write them in order here, B1. And notice what happens. I got an A1, A2, B3, but look at this. I've got a minus A1, B2, A2, B3. A1, A3, B2, do I have one of those? Yep. Plus and a minus. Look at that. How about that? So this does give me 0. And a similar thing turns out, pretty neat, huh? Turns out that if I do the same thing with the B vector, it's going to do the same thing. The dot product comes out to be 0. So that means the dot product of this is 0, it's orthogonal to A. Dot product with B is also 0, so it's orthogonal to B. So this is a vector that is perpendicular to both A and B. Okay? All right, now, I said there's an easier way to remember because it would be, because these are numbers, you know, we're multiplying numbers together, and it'd be easy to cross those up. But there's an easy way to kind of handle this. Let me show you. First, let's talk about, leave that up here so I don't have to write that again. Work around that if I can. Or let me, I guess I will copy it up here. All right, so we got A cross B, A2, B3, minus A3, B2, A3, B1, minus A1, B3, and then A1, B2, minus A2, B1. Okay. All right. Instead of having to remember that, let's talk about determinants. Have you ever done any of that? Okay. With matrices, exactly. Well, with determinants here, just review real quick. If you've got a 2 by 2 matrix, which means 2 lines of numbers, and then the bars there mean we're doing what's called the determinant of that. What we're going to do is do some multiplying and subtracting here as well. Remember what it was? AD minus BC. Yeah. You multiply the A and the D, and then you subtract the product BC. That's always how you would do a determinant of a 2 by 2 matrix, and that's just going to give you a number. So what would 6, 3, negative 2, 4 determinant of that be? (24) minus negative 6, yeah. Yeah, you just have to remember it is AD minus BC, and so it's this times this minus 3 times negative 2. A little different than the dot product. We're just adding, so the sign stays the same. There is a minus involved in the determinant formula, if you will, so gotta watch that. So yeah, this will turn out to be 24 plus 6 will be 30. All right, now that's an order 2 determinant. To do an order 3 determinant, it's a little more involved, right? And the reason for bringing it up is this is what we're going to utilize for this cross product. An order 3 determinant, if we've got A2, A1, A2, A3, B1, B2, B3, and C1, C2, C3 determinant. Remember how that goes? If you take the top row and you're going to multiply each individual one on the top row by a 2 by 2 determinant. And the way it works For A1, we multiply that by, you eliminate, for A1, we eliminate the column below it and the row, and so we just focus in, that's going to be our determinant. B2, B3, C2, C3. All right, now, there's also signs involved here. The next one, with the A2, we're going to go minus A2 times the determinant. If we eliminate the first row, the row of A2, and then the column of A2, that leaves us B1, C1, B3, C3 determinant. And then add again, so it alternates signs. Do that. A3 times the determinant will eliminate the row of A3 and the column of A3. We've got B1, B2, C1, C2. And so then, then the rest is you'd multiply by your determinant of your 2 by 2, multiply the A1 times that, multiply the A2 times the determinant there, like we did on top there. All right. So that's how we do a 3 by 3 determinant. Now, the point of all that is this cross product can be thought of in terms of a 3 by 3 determinant. Here's the way it works. Another way we could think of it, if we go to our alternative IJK format for a vector, it's A2, B3 minus A3, B2 times the I vector. And then we've got A3, B1 minus A1, B3 times the J vector. And then we have A1, B2 minus A2, B1 times the K vector. Okay? That's also how we could write our cross product. Well, here's the way that we can remember this very easily. Look at that. Take the A cross product with B and think of it as a 3 by 3 determinant matrix. The top row is going to be I, J, and K vectors. So it's a little different than a normal determinant because those are the unit vectors. But we'll see how it works. And then the second line is the components of A vector, A1, A2, A3. And then B is the components of B vector. Question? Second row? Oh, B2. Yeah, thank you. Thank you. All right. All right. So, notice how this works. I would take the I times what? The determinant of A2, A3, B2, B3. Then I would go minus the J times the determinant, eliminate the J column and row, A1, A3, B1, B3, right? Let's see if I can squeeze it in there a little better. A1, A3, B1, B3. Remember, that's a minus, though. And then we'll do the K times A1, A2, B1, B2. And notice this comes out the same. Because then this is, and if we write the I mean, we can flip-flop those around. So we have A2, B3 minus A3, B2 times the I vector. Ta-da. Okay. And then minus J, let's see, minus the A1, B3 minus A3, B1 times the J vector. Now, that is a little different than that, but it's the same because if we distribute the minus, that'll be a minus and that'll be a plus. So we've got A3B1 minus A1B3. And then the K works the same way. You have A1B2 minus A2B1 times the K. So set it up like that, and it's really pretty easy, pretty convenient to do. Instead of having to remember which one do I go? You just probably. I don't know. You probably remember it for a while and then forget. But this way it's pretty easy because you just remember IJK, A1, A2. Arrange it like that. Good to go. All right. So let's do one. Cross product of two vectors here. Find the cross product and verify it's orthogonal to the vectors. We've got A is 1, 3, 4, and B is 2, 7, negative 5. Cross product. So let's do the determinant IJK. 1, 3, 4, 2, 7, negative 5. And probably as you do more of them, you be more accustomed, but you take the I then times the determinant of 3, 4, 7, negative 5, then minus the J times 1, 4, 2, negative 5, plus the K then times the determinant 1, 3, 2, 7. And so those are usually pretty easy to do. All right, so we got negative 15 minus 28 times the I. And then minus, it'd be negative 5 minus 8 times the J. And then 7 minus 6 times the K. Cross product, the determinant, just multiply this one and subtract that one. So this one, yeah, you got that one right. Okay. So what have we got? Negative 43I, and that would be positive 13J, and then plus 1. Okay. That'd be the cross product. Now, the second part, verify it's orthogonal. How do we know that? Dot product equals 0. So our A dotted with our cross product is 0, and the B dotted with cross product is 0 as well. Is that true? All right, so A dotted with A cross B. All right, just negative 43 plus 39 plus 4. That's 0. Ta-da. All right, then B dotted with the cross product. Be these two, right? So be negative 86 plus 7 times 13, 81, 91. And then negative 5 times 1 is okay. It'll be 0. Sure enough. Okay. So it's orthogonal to both.